Hi, welcome back. In our previous lesson, we looked at algebraic representation of future and present values. Today, we'll be moving on to some practice questions on the intertemporal choice. So let's start with this question here. Nate earns an income of $240 each month. His preference over consumption over 2 months can be represented by the following utility function, where we have ln C1 and 0.6 ln C2. We have C1 representing the level of consumption in the first month, C2 level of consumption in the second month. Then the interest rate for borrowing and saving is giving us 20%. Now our first question is, write down a budget equation to represent Nate's feasible consumption choice over the 2 months. What we know here is Nate's period 0 or current period is the first month and his future period is the second month. Now, in the first month, his consumption is equal to C1. Given Nate's current consumption, the saving in the first period is going to be I minus C1, where I here is Nate's income in the first month, and C1, as we've mentioned, is the present consumption. So we know that the income is 240 in each month, but we do not know what the consumption first month is. So this is going to be Nate's savings in the first month. Now, what we must note here is if this is negative, then it means that Nate's consumption in the first month is bigger than this 240. Now, that will be borrowing, which means that Nate borrowed in the first month. But if this amount is positive, then the income in the first month is bigger than the consumption, and this means Nate saved in the first month. If Nate saves this amount in the first month with an interest rate of 20%, this amount is going to be worth 1 plus 0.2 multiplied by the amount that is saved at the start of the second period. So consumption in the second period is therefore going to be given by C2 being equal to plus 0.2240 minus C1 plus 240, where we know that this amount is from the first month plus the interest that is earned, and this amount is the income that Nate gets in the second period. Consumption in the second period is going to be a factor of the income that Nate gets in the second month and then the amount that Nate brings from the first month. So we can rearrange this to get C2 being equal to 1.2 multiplied by 240 minus 1.2 multiplied by C1 plus 240. So again, this can be rewritten as 1.2 C1 plus C2 being equal to 1.2 multiplied by 240 plus 240. Then we have C1 plus 1 divided by 1.2 multiplied by C2 being equal to 240 plus 1 over 1.2 multiplied by 240. Now this function here is called Nate intertemporal budget constraint. Now more generally, we can rewrite this function here as C1 plus 1 divided by 1 plus the interest rate multiplied by C2 being equal to M1 plus 1 divided by 1 plus I M2, where C1 is Nate's consumption in the first period, C2 is Nate consumption in the second period, M1 is the income that Nate gets in the first period. M2 is the income that Nate gets in the second period. So you can see that with the income that Nate gets in the second period, which is considered the future period, because we are looking at the present value of this income, we have to discount this by the interest rate. That is why we have this multiplied by 1 over 1 plus I. So this is the general formula for the intertemporal budget constraint. Now this bit over here represents the net present value of consumption over both periods. And this bit here represents the net present value of income over both periods. So this is just like a general budget constraint where we have the expenditure of both goods being equal to the income that the consumer gets. This formula answers the first question, which is using a budget constraint to represent net feasible consumption over both periods. Now let's move on to question 2. The second question, which is using a diagram, show net feasible consumption choices over the 2 months. So all we're going to do here is represent the intertemporal budget constraint on a diagram. Now, using our intertemporal budget constraint, let's recall that our x-axis represents consumption in the first month, which is the current period, and our y-axis represents consumption in the second month, which is the future period. Our x-intercept will be net maximum consumption in the first month. If he decides that he will spend all his first income now and also borrow enough money today against all of his second month income. So essentially, Nate wants to spend every income he can earn over both periods in the first month. C2 is going to be equal to 0. If we go back to our intertemporal budget constraint, we have C1 plus 1 over 1 plus I, C2 being equal to M1 plus 1 over 1 plus I, M2. If C2 is equal to 0, then this reduces to C1 being equal to M1 plus 1 over 1 plus I, M2. We know that M1 is equal to M2, which is equal to 240, which is the income that Nate gets in both periods. And we also know that the interest rate I is also equal to 20%. We can therefore find C1 when C2 is 0, which is our x-intercept. We have C1 being equal to 240 plus 1 over 1.2 multiplied by 240, and this simply gives us 440. So the maximum value of C1 when C2 is 0 is 440. So if Nate decides that he will spend all his income today and also borrow an amount against all of his future income, the maximum amount that he can consume is 440. If we come back to our diagram, this is represented here, where C2 is 0 and C1 is 440. Similarly, for our y-intercept, which is the value of C2, C1 is equal to 0. What this means is Nate will decide that he won't spend anything today and spend all of his income in the second period. So going back to our budget constraint, if we have C1 being equal to 0, our intertemporal budget constraint therefore reduces to 1 divided by 1.2 multiplied by C2 equals M1 plus 1 over 1.2 multiplied by M2, where this is 240, this is 240. So we have C2 being equal to 1.2 multiplied by 240 plus 240. So the value of future consumption, if present consumption is 0, is 528. So the maximum value of C2, if C1 is 0, is this. We see this on our graph represented as this, where our current consumption C1 is 0 and then C2 is 528. Now that we have these two intercepts, the x-intercept and the y-intercept, if we connect these 2 points, we get our intertemporal budget constraint. Given this information, the feasible consumption choices for Nate are the choices on the budget line or in this shaded area. So any consumption level in this shaded area is feasible given Nate's income and then the interest rate. Any point on this budget line is also feasible. So this is all that we have on the first part of our practice question on intertemporal choice. Our next lesson will be on part 2. If you enjoyed today's lesson, consider subscribing. Thank you.